Let's prove part B of the previous theorem. It's asked us to to compute the limit of 1 minus cosine of theta over theta as theta approaches 0. So according to the theorem, we know that this limit is equal to 0. So we don't need to directly apply the squeeze theorem here, but we're going to derive this as a consequence of the previous, of part A, the analysis that we previously carried out. So this is the same as the limit theta approaches 0 of 1 plus cosine of theta divided by 1 plus cosine of theta. So we're going to do something that we've been doing when dealing with quotients in the past. So we're going to multiply by the conjugate, and we have the same thing at the bottom. We're just multiplying by 1, and we get the limit theta approaches 0 of 1 minus cosine squared of theta divided by theta times 1 plus cosine of theta. Okay? And what is 1 minus cosine squared? I mean, that's the reason why we multiply by 1 plus cosine. Because that's equal to sine squared of theta. Remember, the sine squared plus cosine squared is equal to 1. So we get 1 minus cosine squared, which is sine squared of theta, divided by theta, 1 plus cosine of theta. Now we write this as the limit when theta approaches 0 of sine of theta over theta times the sine of theta over 1 plus cosine of theta. And now let's note here that we know that this expression here has a limit, and so does this one. So we can apply the rule for the product, so the law for the product, and we can split this into two limits and take the product of the limits. Sine of theta 1 plus cosine of theta. Here we know that this limit is equal to 1, the first one, because we just computed it, and the second one is a continuous function. Remember, the only problem for this kinds of expression, so if you have a quotient, is when the denominator vanishes at the point, which is not the case, because cosine of 0 is 1, so you just get 2. So what you get here is sine of 0, which is equal to 0 over 2, and 1 times 0 over 2 is just 0. So this is the limit that you wanted to compute. So we will go back in conclusion. So sine of theta over theta goes to 0 as theta goes to 0, and 1 minus cosine of theta over theta goes to 0 as theta goes to 0. This is this is what we've just shown, and this is all thanks to the squeeze theorem and inequality that we're gonna prove next. Now, I wanted to stop here because I took a look at your quizzes and one piece of advice, a little bit of a warning that I'd like to give you is that, okay, so it would be tempting. So some of you may be asking, why can't you just compute the limit of, okay, so let me, so attention, so be careful. Okay, so when computing the limit of sine of theta over theta as theta approaches 0, we cannot apply the law of the product. Otherwise, everything we've been doing this week would be rather pointless. And we'll go over, we'll go over the trouble of introducing the squeeze theorem, doing all that with the product. And the reason is that this expression is not defined, at 0, so you cannot just evaluate. So because if we attempted to do that, so if we try to do that, we would get the limit of sine theta over theta, as theta approaches 0, and we would get the limit of sine of theta as theta approaches 0 times the limit of 1 over theta, theta approaches 0, and people will tell me this is equal to 0 times 1 over 0, or 0 over 0. And you see that here that this is an undefined expression. And notice here this is not equal. This is not equal to 0. I've told you since the beginning that when you get something of this form, so 0 over 0, that this is not a number, so in particular it cannot be equal to 0. This is nothing. This is, if you arrive at this step, you did something wrong. This is completely nonsensical. So you have to, that already tells you, if you're trying to solve a problem, if you arrive at something like this, then it means that you're doing something wrong and you need to check whether you can actually apply the rule you're trying to apply. Here it doesn't, because when you, if you want to take the limit of the product and separate it into the product of the limit, or the quotient rule, then you need to check that the limits exist. So here, if you write it as a product, the limit of 1 over theta, theta approaches 0, does not exist. So you're not allowed to then to use that rule. If you write it as a quotient, remember that one of the requirements was that the limit at the bottom was not equal to 0. Okay, so this law does not apply, and so this is why we need to appeal to the squeeze theorem in order to derive the limit. Okay, so I thought it would make sense to make this comment now, so you avoid making that mistake in the future, because that will make it harder and harder to follow derivatives later on. So please stop doing that. Okay. Okay. So in the next video, we'll go over the proof of that inequality relating sine theta over theta, cosine theta, and 1, which we use to derive the famous limit of sine of theta over theta. Oh, in fact, I made a mistake here. This is not 0. This should be equal to 1. Sine of theta over theta goes to 1. Theta approaches 0. Okay, and 1 minus cosine theta over theta approaches 0. Okay, so this is for now. Go over the proof in the next video.